So we're still on probability, but now we're looking at probability distributions, okay, which is chapter 4. Chapter 4 is based on probability distributions. Right? Probability distributions. I mean, guys, you need to understand that stats is based on analyzing data, right? Now, let me do a quick sketch for you guys. In everyday life, we've got what is known as population, right? And from the population, you've got a sample. A sample is a subset of the population. Okay? Sample, right? To get this sample, you use the type of sampling methods, right? It's either you use probability based sampling, right? So it's either you use probability based sampling, which can be simple random sample, or systematic sampling, or else stratified sampling. Okay, stratified sampling, right? All these are probability based. Now we've got non-probability based, right? Non-probability based, right? This is like convenient sampling, right? What do I mean about the type of sampling which is probability based? The type of sampling which is probability based is a sampling where everyone has an equal chance to be sampled from the population and to be in my sample space, right? But non-probability based is where not everyone has an equal chance to be sampled and be on my sample space. Okay, so now let's talk. So now, I mean, we know that there are parameters, population. There are parameters here, right? And parameters are referred as being constant, right? We also have a sample. In a sample, obviously, there are statistics, okay? Right. Statistic is referred as being the estimate, right? What are you estimating? You're estimating these parameters, okay? Now, I want to talk about probability distributions. So obviously, there are going to be some information which is referred as a statistic that you'll want to get from your sample, okay? So for the fact that you used maybe a probability-based sampling to get your sample, obviously the information that you'll have will be of probability. Now, that's where probability distributions come about. Let's talk about that now. Okay? Probability distributions. Right. Okay? Now, this is the content I'd like us to cover. Okay? You've got basic statistics. You've got these types of probability distributions. You also have approximations. Right? Let's talk about basic statistics. Right? Basic statistics. Just use this. Yes. Basic statistic is if you're given raw data and you're being asked to find your average, your mean, I mean, you know that, for example, throwing a die, right? Probability of x. Throwing a die, it's either you die, you'll get a 1, a 2, a 3, a 4, a 5, or a 6, right? Now the probability of getting a 1 from a die is 1 over 6. Is 1 over 6. A 2, 1 over 6. 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 Right? The probability of getting a 4 is still 1 over 6. A 5, it's still 1 over 6. So what you need to understand is that the summation of all the probability of xi equals to x must be equals to 1, right? What is the expectation? The expectation of xi is equals to the summation of xi times probability of xi equals to x, right? Of x equals to xi. Of x equals to xi, right? What is the variance? The variance is equals to the summation of xi squared times the probability of xi minus the expectation of xi all squared, right? You just need to know this under basic statistics, okay? If you're being asked what is the average of this, then you'll know that is the summation of xi times the probability of xi. If you're being asked to find the variance, you know that is the summation of xi squared times the probability of it minus the mean, minus the average, which is this, okay, all squared. Okay, now let's talk about types of probability distributions. But before we go that, let me talk about weighting in stats. Weighting in stats, there are these words, at least, at most. This is number 1, this is number 2, at most, right? More than, number 3, more than, right? In between, less than, yes. Now I always make example of money, right? I mean, who doesn't like money? So if I can ask you, can you borrow me at least 10 rand? What do I mean? I mean that I need you to borrow me 10 rand or less, right? So this means it's this guy. Okay, these are inequality words. At most, can you borrow me at most 10 rand? This means greater than, right? More than 10 rand, right? In between, this means A and B. Okay, and less than. Okay, now in probability distributions, there are two ways they could ask you. It's either it's equality question. I mean, equality is equals to, right? To solve this, you need to use the PDF under each probability distribution, probability density function. Okay, we'll talk about that. And you've got inequality, right? Where inequality now, it's either these guys. So there are two ways, okay? So before we do probability distribution, you need to understand everything that's here, okay? So how many probability distributions do we have? We've got binomial distribution, we've got Bernoulli distribution, we've got Poisson distribution, right? We've got hypergeometric distribution. Okay, distribution, right? Okay, now all these distributions are of discrete data. All these guys are of discrete data. Okay, these are distributions of discrete data. Okay, so let's talk about binomial distribution. Binomial distribution, binomial means many, right? Many. Binomial distribution comes about if the question has only a sample and only, need to underline this, a sample, which is n, and the probability of success, right? Which is just one probability of success. Okay, okay, and one probability of success, right? So which is probability of A. For example, throwing a die, right? Throwing a die, you given n, which your sample space is 6. The probability of getting any number from a die is 1/6, right? You only have your sample and your probability of success. So if I'm only given these two, I'm dealing with binomial distribution, right? What do I need to understand about binomial distribution? Firstly, it's binomial, we said many. So you see, there is more than one sample. So under binomial distribution, what do you need to understand? The expectation of xi under binomial distribution is just n and p, right? Which is n is the sample that you're given and p is the probability of success. Variance is npq, where q is equals to 1 minus the probability of success, right? This is what you need to understand under binomial distribution. Again, what is the PDF of binomial distribution? The probability. Remember, I said you can be asked in two ways. It's either you being asked to find the probability of equality or you're being asked to find the probability of inequality. The probability of equality, you use the PDF, right? This is the probability of success, xi, 1 minus probability and n minus xi, right? If you're being asked to find the probability of inequality under binomial distribution, use tables, right? Statistical tables, right? Mind you, those tables give you the area to the left, So if you're being asked to find the probability of xi greater than xi, you need to know that you need to say 1 minus the probability of xi minus x minus 1, right? Okay, so let's go to Bernoulli. Bernoulli is the same as binomial distribution. The only difference is that your n, your sample, in this case will only be 1. Will only be 1 instead of more than 1, right? So everything then is the same. If that's the case, it's Bernoulli. So what is the expectation under if it's dealing with Bernoulli distribution? It's just P because your n is 1. Your variance would be just PQ because your n is 1. Again, where you see n here, you'll put 1. Okay, now let's talk about Poisson distribution. Poisson distribution, right? Again, what do you need to understand about Poisson distribution? If in a question you are only given average, then you're dealing with Poisson distribution. Okay, for example, if you go to a petrol station, the average of cars that go into place per hour is, right, is 5. So you'll know that my average, this is example, is 5 per hour, right, per hour. So I'm given average and a constraint. So I know that I'm dealing with Poisson constraint, right? So I know I'm dealing with Poisson distribution. Poisson distribution deals with count data. Again, if I'm being asked to find the expectation under Poisson distribution, it's just this average that I'm given. So the expectation, right? Now remember, this average goes with per hour. They can change this constraint. So you need to know that if they change this constraint, the average you look for must be in line with whatever they've changed it for. Maybe they can say, what is now the average per minute, right? Then you'll know that how many, then you need to convert your hours into minutes, right? Okay. Then again, your variance of xi is also mu, right? It goes along with the constraint that they've given you. Okay. So again, what is the PDF under Poisson distribution? P of xi is over x bar mu e minus mu xi, right? So when do you use the PDF? If you're being asked to find the question of the equality. Again, if you're being asked to find the probability of inequality and you're dealing with Poisson distribution, use tables. Okay, hypergeometric distribution. How do you see this one? Right? How do you see hypergeometric distribution? If in a question you are given a population, no probability, just a population, and from this population you are told about multiple samples, right? For example, if I tell you that I've got a bowl, right? In this bowl I've got 4 balls, right? Got 4 balls. Now this is my population. Out of these 4 balls, 2 are red, 2 are blue. Then I know that I'm dealing with hypergeometric distribution. Again, guys, to find more clarity on this, you need to go through the notes, and do the exercises again. Thank you.